Okay, so what we're going to work through here is the first example. We're going to look at how we break up each of our vectors into their vertical and horizontal components for each vector, and then move through the process of adding them both together and determining a resultant. So the reason we're doing this is if we were to look at A and just deal with A's horizontal component, and then B's horizontal component, and then A's vertical component, and then B's vertical component, of each of these triangles, what we'd end up getting is what happens when you add those components together to get our resultant. So that's what we're going to do here. We'll start off with A. So if we look at A as though it's a triangle, we've got a 28-degree angle here, and we've got a magnitude of 15 newtons. If we're dealing with this side, looking to find this side, it is the opposite of the angle. So we're going to use sine theta equals the opposite over the hypotenuse. So that's what we're going to deal with there. This being the opposite side, this being the hypotenuse. So we have sine theta, which is 28 degrees, equals our unknown, our opposite, which really is our vertical component, over our magnitude here. Okay? And if we're looking at the horizontal, we've got the same situation, except we're dealing with cos theta equals the adjacent over the hypotenuse. So if we look at this, we've got cos 28 equals the adjacent, which is our horizontal component, over the magnitude of our angle. Now, for each of these, if I've got sine 28 equals the vertical over 15, I can apply my linear algebra to make the vertical component the subject here, and I do that by multiplying both sides by 15, and that gives me the vertical is equal to 15 sine 28. If I do the same thing with cos 28 equals my horizontal over 15, if I multiply both sides by 15, I get my horizontal is equal to 15 cos 28. So there we go, I've got my vertical component and my horizontal component for vector A. If I look at vector B, I'm going to do the exact same thing, except in this one, I'm given this angle here. If I want to take this perspective, then all I need to do is apply some geometry skills and know that this is 60 degrees here. The magnitude is 20 newtons. So if I look at the vertical component will be the magnitude sine the angle. And my horizontal component will be the magnitude cosine the angle, given that we're dealing with this angle here. So B's vertical component is equal to 20 sine 60, and B's horizontal component is equal to 20 cosine 60. What I need to do in order to go A, B equals my resultant is take each of the components and add them together. So I want the vertical components and I want the horizontal components to get the components of my resultant, and then we'll go from there. So this one is going to be 15 sine 28 plus 20 sine 60. So taking our vertical components and adding them together. I'll do the same for the horizontal component. So I've got my horizontal here of 15 cosine 28 plus 20 cosine 60. Now I'll need to evaluate what each of those are in my calculator. So I'll type in 15 sine 28 plus 20 sine 60, and that gives me 22.5, 6, 7, etc. newtons. If I evaluate this one, I've got 15 cosine 28 plus 20 cosine 60, and that gives me 25.328, etc. newtons. So what I've got is my two components. I've got my horizontal and my vertical component of this vector. My vertical has been given as 22.567, etc. newtons. My horizontal as 25.328, etc. newtons. I need to know the magnitude of my resultant. I can find that using Pythagoras' theorem. So the magnitude of my resultant is going to equal the square root of 22.567 squared plus 25.328 squared. So you do need to be careful here that when you put this in the calculator, you are grouping all of this. So we'll go square root, open brackets, 22.567 squared plus 25.328 squared, close the brackets, hit equals, and I get a resultant of 33.9 newtons. So that's 33.9 newtons. The last thing to do is to determine the direction in terms of this angle here. So in order to determine the angle, I'm going to need to use trigonometry again. This time I'm going to use tan. It says tan theta is equal to the opposite over the adjacent. Here's my opposite and here's my adjacent. What I'm looking for is the angle. So what I need to do is again employ linear algebra techniques to make theta the subject. Essentially what I'm doing is inverting both sides by tan to bring it over to this side. So what that gives me is theta is equal to inverse tan times the opposite over the adjacent. So my opposite is 22.567 and my adjacent is 25.328. So what I'll do is I'll now plug that into my calculator, and to do that, to get my inverse, I'm going to hit shift before I hit tan, and you'll notice that I do get the -1 come up next to tan. I'm then going to do 22, and I'll put this in brackets, 22.567 over 25.328, hit equals, and I get 46.33 degrees. Okay, and that gives me the direction of my vector. Hopefully this helps you out with the next ones.